So there it is. I'm going to share the screen. Okay, so I'm sharing now. I believe it's recording. Yeah, it's recording right there. Uh, Oops. Share. All right, so I think we are sharing. Yeah. All right. So this should be Brightspace. So if you've never used Brightspace, you know, you can come here. I think this is section one. Do you guys know if you're on section one or section two? Section one. All right. So uh do you have access to this? Can you so they automatically opened it. Okay, great. So yeah, so this is Brightspace. I've loaded most of the materials already. Essentially, I put everything in content. Okay, so you can see that there, table of contents, and then I have all the material there. All right. So today, I'll go over the syllabus, of course. I'll go over the materials that I have here on Brightspace, different links that are required, and then we're going to get into the first topics. I have a simple set of slides that has some terminology, and then the way that I like to start the course is usually I start with something called word problems and then tensor operations. So it's just building up to more complex things. Okay, so this should be ITS 520, which is called Applied Machine Learning, right? So you should all be in the correct place. All right, so this is the table of contents. These are all the materials kind of in sequence. Today, we'll go over all these modules here, including intro, ML word problems, and start a little bit of tensor operations. Okay, so that's kind of the idea. And then so I'll motivate the class. I'll talk about it. So the first module that we can look at is really admin. This is where I'll post things like the syllabus, things like that. So you can see this is the syllabus. I'm gonna click on it and I'm just gonna go over it, kind of give you some information. All right, so ITS 520, it's applied machine learning. It's meant to be an introductory course to machine learning at the graduate level. Okay, so that's essentially the idea. The way that I would put this is we're gonna be doing machine learning from scratch. Okay, versus we have another course, ITS 530, which is more of the applied deep learning, and that one is more of a transfer learning course. So if you know what that is, with a transfer learning course, you're actually taking pre-trained models and you're fine-tuning them or just using them to solve problems. So they take a BERT or a large language model and use it to solve a task. That's 530, which is the second class, and then this one would be the first class, which introduces how to build your own neural networks from scratch. It focuses on PyTorch coding in Python, for instance. Okay, so that will be the basic idea. So this course runs in the fall. We're going to meet, there's two sections, one today, Monday, from 5 to 6:20. We'll take a 10-minute break from 6:20 to 6:30, and then from 6:30 to 7:50, the second half of the course. Okay, and that will be usually what we're going to do. Okay, and then there's the other class on Thursdays, which for the other section that kind of runs in a similar way. So I'm Professor Calix. I'm in Anderson 238, so you can see that there. My office hours are going to be Mondays and Tuesdays from 2 to 4, right? So you can find me in my office. Otherwise, you have to send me an email to schedule an appointment. Yeah, so that's my email, phone, in my office. So let's go over the course description. So ITS 520, Applied Machine Learning. This course, let's see if I can figure. All right, so this course covers the theory and technologies related to applied machine learning. In particular, the course focuses on the analysis of data produced via web applications and social media, which if you think about it, that's basically all data, right? Today. Topics to be covered include, what I call the machine learning pipeline, what everyone calls the machine learning pipeline. So data pre-processing, so we'll go over that. Machine learning in the context of big data, so that, how to generate models with a lot of data. Data scraping. So I usually like to do one of those in this course, which is like a crawler type of a thing, collect some data so you can train things from scratch, right? So again, the idea here is to not use transfer learning, not use models that are pre-trained, instead you build everything. And so that's why we started at a very basic level with tensor operations, which I'll discuss in a little bit. Data scraping, features and feature extraction. So you'll learn a lot about features. They will become a very key term that you have to understand. The vector space model. So that's a very big, important concept, right? So it's in the syllabus. And so we'll learn what that is, the vector space model, and to think in terms of that. The course covers data mining of unstructured data, of course, which basically means like text, right? That's a good example of unstructured data. So, I'll talk a little bit of just kind of the main topics that we'll cover. Traditional machine learning methods of data analytics. So usually I'll divide machine learning into like two categories, something like the classical or traditional machine learning, and then the more advanced machine learning. So that's going to be your deep learning versus, some other algorithm. It doesn't mean that those methods are bad. Sometimes those methods are really good. And so we're going to learn a little bit about them. The focus is a lot of the content will focus on neural networks and deep learning, but I will cover some of the other topics as much as possible. So there will be traditional machine learning methods, and then, of course, an introduction to deep learning. And just because it says an introduction to deep learning, that doesn't mean that we're not going to cover a lot, right? So actually, the course covers quite a bit. And then, of course, you have to evaluate your models. So we're going to do machine learning evaluation methods, which is all the performance metrics, the classical ones, and then there's a few other ones, and special topics as as they become available. All right, so here's some of the learning outcomes or course objectives. So to understand the basic machine learning pipeline, and what I mean by that is going from the data all the way to a trained model that you can use and evaluate the performance of it. Understanding of data scraping, understanding of machine learning in the context of big data, pre-processing techniques, features and feature extraction, the vector space model, traditional versus deep learning, the evaluation methods, and of course, collaborate. There will be a term project, so collaborate with team members to resolve machine learning problems. And you can also conduct independent research. So let's talk a little bit about prereqs. So essentially, this is meant to be an intro to machine learning, but you should know how to program, right? So that's assumed. Now, programming for machine learning is not difficult. I should say that. It's very basic things that we're doing. And really, the new thing is how to code the neural networks, how to code your machine learning techniques. All right, so usually since this is a ITS course, usually the prereq is ITS 450, which is called software assurance. It's like one of the last classes in the software track. Or you can either have that course or if you didn't do your undergrad here, just knowledge of programming, let's say up to data structures and some statistics would be good, right? So that will help you. Already talked about the hours. This is a 3-credit course. The text, I'll provide the materials. As I said, I have a whole bunch of blog posts and things like that you can read through. So that I follow. If you want to have a book, this is a good one, Deep Learning with PyTorch. So any PyTorch book, right? So that's honestly what I would recommend. if you want to get a book, but it's not required, right? I think I have like all the information on how to code with PyTorch and build your neural networks. But yeah, this book, you can just get the latest edition or something by Sebastian Rashka that also involves PyTorch. Either one is fine. Pretty much they're all the same. So, any questions on any of that so far? Okay. Yeah, so I'll provide the materials. I've covered, these are some of the topics, so I won't repeat that. The course grade. So here, this is usually how I do it. So exams are 30% of your grade. There will be 3 exams, one on week 6, one on week 12, and one during finals week. All right, and each one of those is worth 10% of your grade. They're essentially based on the topics that we cover in the course. The term project is worth 20% of your grade. It's a grad level class, so I'm not going to give you an assignment every week or anything like that, but the assignments can be a little bit complex or big, so we'll do a few of those. So that's why I use here either assignments or mini projects, right? So you can think of them as one nice thing with these assignments is that you're doing interesting things, so sometimes you'll present your homework also, right? These mini projects. So we'll do that a couple of times, maybe before the project presentation. Does that make sense? And the difference usually is that the mini projects are individual, whereas the term project is a group effort, 2 to 3 people. Okay. But yeah, in the past I've done that. It's just the nature of machine learning. It's, you'll do training a small large language model with some data, or generating images using stable diffusion, something like that. It requires a lot of work, so it's kind of nice to present those. All right. Yeah, so you should read through this information. There's a lot of policies, grading. My biggest thing is homework needs to be submitted on Brightspace. Okay, that's usually where the biggest problem is. So I don't accept homework that's submitted via email. Remember that you need to submit homework assignments on time because Brightspace will close. So that's what creates the problem where you guys sometimes want to send your assignments via email. But as a general policy, I don't accept homework via email, and I ask you to submit via Brightspace. Attendance, as I said, I believe it's required for you guys to attend. All right, you should read through these. These are other policies, student disabilities, all that. Please take a look at those. All right, so this is the tentative course schedule that I follow. So essentially, introduction to machine learning, the basic machine learning pipeline, right? So we'll cover that today, what I mean by that. Data processing, a lot of the work sometimes in machine learning is dealing with the data. Once I show you how a stable diffusion algorithm works and you understand, you can pretty much use that many times. You know what I mean? So you learn these algorithms, and once you know how to use them, you don't really have to change them that much. But your problem will change, right? And usually the difficult part is going from the raw data to the formatted data that will go into this algorithm. So a lot of that's essentially the hard part. So you'll have, that's usually why I do that crawler assignment, because it's not really the machine learning, it's just getting the data and formatting it correctly. So you'll see what I mean by that. But some people will say that 80% of the work is dealing with the data. That actually has a funny name, which is called data wrangling, which is essentially like dealing with like wild animals or something, right? So it's something wild, and it's called wrangling sometimes. So it is a bit of a challenge. So there will be some assignments or homework assignments that will have very nice data sets that are already formatted appropriately, and some that will be more open-ended, right? And that's the challenge. All right, once that, I'll cover a few, not many, of the traditional machine learning algorithms. Sometimes especially for the traditional ones, I'll discuss the algorithm itself, or maybe I'll just point out how to use the algorithm with some data. All right. And usually my focus is more on neural networks and deep learning. So we'll start, building that up with PyTorch so that you have a good understanding. So we cover pretty much from just normal linear regression. I'm sure you've covered that at some point in some course, all the way to a deep neural network, a CNN, and then I like to do an LLM, like the GPT part of an LLM, and also stable diffusion. These are, of course, very simple versions of the algorithm. It does, but I think, that's kind of the progression. Okay. So you can expect that's the focus of the course. Now, with all of these, you will be pre-training from scratch. So you will be training the model and you won't be using any transfer learning or anything like that. All right, so yeah, so you can see the algorithms here. Usually the sequence is like regression, linear regression, nonlinear regression, of course. Um, and then, just simple neural networks, deep neural networks, CNNs. I don't like RNNs, so I don't cover those. And, GPTs actually kind of do the same. So I kind of do that instead. So, but yeah, that's the basic logic. There's a big leap between you'll see that actually building a deep neural network is not very hard, but building an LLM is hard. There's like a huge leap from one to the other. Okay. And so that's why because there's a lot of like linear algebra operations going on in the background. So that's usually why I start with this idea of tensor operations. Okay, which I will motivate today. Might even start playing with that today. And I have like 100 or so type linear algebra type problems that I call tensor operations. And essentially what I ask you to do is just to keep repeating, do them over and over and over again, and develop a type of muscle memory, if you know what that means. And so eventually things will start to click but we'll discuss all of that. But it's essential to understand. So basically to break down the big problem into much smaller little problems. All right, so you can see here, so kind of the idea is to cover regression, features and feature extraction, traditional machine learning algorithms, machine learning and big data, some of the implications of that, which, when you say big data, obviously that means, a lot of data that your CPU may not be able to process. Okay, so in this course, you will require to use like a GPU for some of the tasks. But nowadays, that's pretty easy to do because you can just use Google Colab, for instance, that works really well. So one of the things I recommend right now, not right now, but in this week, is find out what Google Colab is, right? So go in there, get on it, and at some point I will do a demo of how to get started with it. But the advantage with something like Google Colab is that you get a GPU, right? So, computers have CPUs and they process fast, but a GPU has more power to process things in parallel. So I promise you, you're training, something like a Cyfar 10 data set of images. And if you're just using your CPU on your laptop, that's 5, 6 hours, right? 7 hours training. And then you have to repeat that over and over because you're making tweaks to the architecture, and that can really not be fun, right? So instead, what you want to do is you switch over to Google Colab, or if you have your own GPUs, and then you start processing things in 20 minutes. Do you see what I'm saying? So it's just going to be much faster. So we'll learn about that. GPUs are essential to machine learning, at least today. I mean, some people will say that transformers and GPTs exist because of GPUs. Like they were literally designed to run on GPUs. Okay, so GPUs are important. So Google Colab definitely is very important. Kaggle also provides kind of the same thing, so you can try that out. Unfortunately, well, they're free. The only problem sometimes is that they limit you to 2 hours of training. So that might happen, but even that can be bypassed. You can just like, run it for like an hour and 50 minutes, save a checkpoint, and then from that checkpoint, you can start a new run and continue training if you need to do that. We hardly ever need to do something like that, but you never know. So anyway, so we'll talk about a lot of those things, but for now, just the environment will be, you can use Colab, and sometimes I'll use Colab, but I will also show you how to run it locally on your machine. So for that, we can use Anaconda, for instance. So that's another thing. If you've never used Anaconda, just that you can Google that, start downloading that software, and then you'll be able to create environments. And the great thing about that is sometimes when you're developing an application, you need to have different versions of NumPy or PyTorch or some other library. And something that works in Python 3.7 may not work in Python 3.10 and so on. And so having something where you can manage environments is really important. So Anaconda is really great for that. All right, so those are the two big ones so far, Anaconda and Colab, I would say. So I like Colab. So we'll talk about that, how to load your data. Usually to load your data, you're going to need to have your OneDrive, for instance. That's kind of how it works. So you have your Google OneDrive, you connect them somehow, which I'll show you how to do that, and then that's it. All right, once you figure that out, it should be pretty easy. And nice. All right, so yeah, so there's no midterm because there's 3 exams. So you can see exam 1 will be like around week 6. We'll do deep learning. When you start, so traditional methods. So deep learning just means that you have a neural network with more than 2 layers, right? But you can build traditional classical machine learning algorithms using the framework of PyTorch that's building up to deep learning. So you can do linear regression, nonlinear regression, logistic regression, a multi-layer perceptron, which technically is not deep learning, right? So those are technically classical or traditional machine learning algorithms. But I'll start kind of from those basic things building up. I just won't start at the perceptron, for instance, which is something I cover in 365, but not here. All right. Yeah, so we'll build up on all of those. That sequence is pretty, goes together really well from regression all the way to deep neural network. Then after that, we'll look at one of the advanced algorithms. The obvious one is convolutional neural network, CNNs. And then from there, I usually just like to jump to LLMs and stable diffusion. There might be a few other techniques that we cover that are new. All right, so that's deep learning. So you can see that basic neural networks, transformers, GPTs. GPTs can be hard, but at the same time, they can be you can learn to understand, right? So you just have to break them down into the different parts. Stable diffusion also, it's something else that we can take a look at. So deep neural networks, they tie into CNN, so that's really great. Optimization, of course, will be a big thing that we'll cover, as that's the methodology for training these models. But so we'll cover that as how it, MSE and cross entropy and all that. And then special topics, depending on developments. Last year, I think when I was teaching this class, DeepSeek all of a sudden appeared, right? So you never know with AI. There's a 5% probability that something better than LLMs is already out there, right? So you never know. But so yeah, so we'll discuss that. All right, that's the syllabus. You can see here, I'm supposed to give this to you. So these are what emergency procedures. So read through that as well. All right, that's the syllabus. Are there any questions? Nope. And there's a sign-in sheet going around, so please make sure to complete that. Who has the sign-in sheet? Did you all sign in? No? So can you please pass it? All right, so that's the syllabus. So the next thing I will do is just show you kind of where everything is on Brightspace. I'll show you where everything is on like the website, your reference points. And then after that, we can just get started. I have a simple set of slides to cover some terminology. And then we're going to do something that I usually like to call word problems. So we'll take a look at that and then from there, tensor operations, where we finally start to code. So we'll start doing a little bit of coding. All right, so let me see how I can close this. All right, so I'm going to go back to the table of contents. All right, so as you can see, this is the table of contents. So I have a few links here. Some, Python background and commands. So Python obviously we'll be using. Here is the link to Anaconda. So go there if you haven't done so already. Download the program. I'm using Windows on this machine. I also use my Mac. So Anaconda works really great whether you're using Mac, Windows, Linux. It's really great. So just download it. And then later on, I'll show you how to create environments and all that. Once we get into tensor operations, I'll go through that whole process. But for now, just make sure you install this on your computer. So under resources, I also have, I think the videos are here. Yeah, so that's the YouTube channel. So just go to videos, the latest video that relates to your topic. I usually just post these so you can, as I said, follow along. If you missed the lectures, you shouldn't miss class, but if you didn't understand the topic, right, you can see it again. All right. I don't think I have. Okay, so the code, let me get to. This is the code will be in these two links. So let me just add these. This is like where the 520 repo, and I think I wrote 520 in here. Yeah, ITS 520. So that's kind of like the official one. So I'm just gonna say here, I think create a link should work. ITS 520 code, providing the URL so you can find it there. The resources. And then I'll provide a second link where I have like other algorithms kind of related to the course. So this one, deep learning algorithms. And we'll talk about this because I do have a whole bunch of like blog posts that you can read through. So sometimes my notes I've just made available electronically. So you can just read through that as well. But I'm going to add this there. These are some of the algorithms. Control copy. And I'll just create this link. I'll just say additional notes. Code and notes. So this one will have, there's more than just code. There's like explanations and things like that. All right, so that is that. So let's go back to table of contents. So under resources is where I have all these things. So again, you can find Anaconda links, the videos, and then the code and everything like that at these things. Okay. All right. So that's the idea. So for instance, just to kind of navigate here. So 520 PyTorch, right? So it's everything related to deep learning. I kind of just throw in here. And then every semester we go over the code and maybe we fix some bug or something. So I upload the latest version. There's information on GPTs, regression, basics, stable diffusion, and so on. So these are the different topics that we will be discussing this semester. So a lot of these are just algorithms. Okay, so essentially how does the algorithm work? How do you train it, using it, and so on. Okay. All right. And then here I kind of have them broken out as well. So transformers, traditional ML, CNNs. So I will be selecting some of these as we progress through the material. All right, so those are some of the resources. All right, and then I think that's it actually. So that is the syllabus. Word problem. Yeah. So the next thing is, okay, so are there any questions? That concludes like the administrative part, the discussion for today. And now we're ready, I think, to get started with the lecture. So any questions before I proceed? No questions? All right. So these videos are kind of more targeted and you don't have to, I usually want to, it's better in this one.